We dove into stuff on Monday, like an overview of what we could be doing. And what I want to do now is go back and do step by step the tools that we need to actually work with accuracy and knowing what we're doing, as opposed to just sort of throwing stuff onto the screen. What I mostly want to deal with today is drafting and really figuring out how to place walls accurately. And then on Monday, get to doors and windows, because I want you all to be able to put into your apartment models something very close to the doors and windows that are really there. If it's a casement window, to do that, the size right, the height right, and the same with the doors and any trim that's on them. I think let's just start a brand new drawing from scratch, if you would. I think this is something we want to be doing together. And again, I would like to use the Imperial architectural template so we don't get stuck with a lot of extra engineering stuff. And one of the reasons to have started with AutoCAD is to have gotten used to the idea of drafting with a computer, using it to draw things, because there's still a lot that we need to draw flat in 2D in Revit. Things that are flat, like title blocks and I say north arrows and that kind of stuff. We just need to know how to do that and make them crisp. Other things like that are schematic, like if we were doing, as the architects, we want to show on a ceiling plan that light switch over there controls, whichever lights it is. That's just done with curved dashed lines in a ceiling plan. We're not installing conduit. We're just telling the electrician this is the effect of what we want to do. Have these lights all gang together. So there's that sense. And then the plumbing riser diagram that we were looking at in Molly's class. It's just schematic elevation of the building showing the toilets and where the drains go and how they go down. And that's not 3D modeled. That's just drafted schematic. This is what we want to happen. Somebody else has to figure out how that actually works. So a lot of diagrams need to be 2D, and that and sometimes they're ones that we're responsible for, and sometimes they're one that somebody else does that we need to know how to interpret. We also use 2D drafting for, let's say, an important detail like how things are fastened together that we're not going to take the time to model carefully in 3D with bolts on the threads and that kind of stuff. That'll just be drafted with two-dimensional stuff. So that's like adding detail. And sometimes you end up using 2D drawings to represent complex 3D objects. For instance, an Aeron chair, there are a couple of models of that have all the surfaces and facets and connectors and that kind of stuff. And if you saw that in plan with all that 3D stuff sort of compressed into 2D, it would just be a solid mass of ink. And there's no point doing that. So we can tell Revit, simplify this down to just contours that we trace so it looks appropriate. And lastly, in Revit, every three-dimensional object is based upon one or more two-dimensional objects that we then manipulate or add or subtract from. So if you can't make 2D things accurately, 2D shapes, you can't make 3D ones at all. This applies to abstract shapes as well as to regular building components like a floor. And whenever we're starting to create some three-dimensional object, we always get our 2D drawing tools here. And I just want to click and make a rectangular floor and then say OK. And if we look at this in 3D, it's just a floor whose top is right at our level 1. And we have two kinds of lines in Revit. We have model lines correspond to a real 3D thing, like a clothesline going across somewhere. In this case, we'll just draw a line on the floor. We go to architecture, model line, and just draw it across there. We can see that has real location in three-dimensional space. So let me go back to my level 1 floor plan. This project browser should always be on, and it will take you to appropriate views that you want to see. So here's my first floor plan. The 3D view, you can just click on that little house and get you into that view, and then you can rotate around. Okay, so we have a floor, which is really just there for reference. And we also have a model line. Maybe I'll do 2 of those right now. You can draw them in regardless of which view you're on. This view, level 1, is associated, when it was created, with that level 1 level. So anything that we create will be going right in there on that flat plane. These lines, the ones made with the model line, think of them as like a piece of rope lying on the floor there. And so regardless of the view that we're in, those will show up. If I go back to my plan view and create a camera perspective from out here looking at that floor, you can see that they're there as well. Those are real things. They're skinny, they're only a pixel wide, but they show up in all views, just like a chair would show up in all views. It's a thing. And that's different from the ones that we'll use to annotate on a view. I'll go back to my floor plan. If I want to annotate this view with either some text or some dimensions or maybe some lines and arrows that are pointing things out, in Annotate, I can create what's called a detail line, which only show up in the view that they're created in. And we'll see in a bit why this is important. So if I pick that, I have the same bunch of tools. I'm going to just draw a line like this as a detail line. And that's only in this view. So if I go back to my 3D view, it's not there. Any of these can be given a line type. If you select it, we change it to a center line, which has the short dash line pattern. It can be changed to overhead, generally accepted ways, how you represent a wall cabinet in a floor plan, just to let you know that it's there, or a soffit or something like this. Or let's just say wide lines. And sometimes it's helpful to see these being wide, and sometimes it's not. We can toggle the display of wideness with this fat lines, thin lines thing. When that background is white, the line weights are turned on. When it's blue, they're turned off. Revit always plots with line weights turned on. When you're dealing with a smaller screen and don't want your menus to take up lots of space, you can use this button here. It's right at the end of your little main menu here, to go back and forth between displaying this information at smaller and greater levels of detail. And I really recommend you keep it here, just so you can see what all your options are. Keep clicking till you see everything. Once you know where things are or have keyboard shortcuts working out, you can shrink that down and get a little more screen real estate. But at this point, that would be really counterproductive. You just won't be able to find what we're looking for. Okay, so we got the two kinds of lines. We have the 3D lines that exist in all views, and then the detail lines that exist only in the view in which they were created, in this case, the level 1 floor plan. They can all have a line style associated with them, and we can create our own. If we want red lines, we can make a line type called red lines, and they'll be red. But generally, Revit is working with as few colors on the screen as possible. I think to keep what's on the screen as close as possible, it's going to be coming out of the plotter. If there's no need for color, it defaults to monochrome. So what I really want to look at is the tools that we have for drawing lines of either type. It's identical. We'll use model lines for right now, just so we can see what's going on. Architecture, model lines. So we have lines. If we just keep clicking, we get a continuous series of them. This isn't a polyline in the AutoCAD sense. Revit really doesn't have a continuous multi-segment line type. If you want to select all these at one time, things that connect corner to corner, if you hover over any one of them and hit the Tab key, Revit will look for everything that's connected end to end of that same type, only ones that are touching. And we'll get into selection methods later on. Rectangles, as you know. Unlike AutoCAD, Revit doesn't have the ability to specify a second point directly using the syntax with at, like at 12 feet, 8 feet. The idea is you get close, and then let's say I wanted this side to be an even 9 feet. I'd select this one. And basically that means I want to move this down a foot. So I select it and then click on the temporary dimension and say 9 feet. And this is a big difference from AutoCAD. The dimensions control the objects. If I'm drawing a rectangle, LI, rectangle, And it's got, and it, depending on how you're zoomed in, it will, you can see it's sort of rounding off to the nearest foot if I'm, or 6 inches if I'm zoomed out like this. Finer increments, the farther in I go. But if you needed that to be 4/8 and 3/16 by 3/6 1/4, you would just get close and then pick the one that you wanted, 3'6.25, and then it would do it like that. And I rebelled against this at first. I want to be exact right from the very beginning. It's really easier to do it this way. Revit displays dimensions with the hyphen in there, but if you're actually typing a dimension, you should do 4 feet. Feet is all it takes to separate feet from inches. 4'8". If you want to do like 1/4, you use a space, not a minus sign, not the hyphen, because Revit will interpret that as 4'8" minus 1/4, which you don't want to do, like a little formula. So 4'8", 1/4. So the foot mark separates feet from inches, and the space separates inches from fractional inches. Making the other shapes, these are much the same as with AutoCAD. Polygons, whether you're going to pick a point or somewhere on the edge, circles. A couple things about the curves. This is a really very nice one. The AutoCAD is really a pain to do an arc that goes from here to here and then up there somewhere. This is really nice. This is the one that lets you click a point here, click the end point, and then just pick where that wants to be. It's just a nice way to do it. And if you drag it up far enough, it'll click in there where it's tangent to both of the lines that were picked. So just a smooth curve all the way around, or it goes farther. And with all these, again, you can pick the thing, pick the dimension, 8 feet. Oh, the center stayed in the same place. That's what was happening. And it got bigger. Also, unlike AutoCAD, if we do one of these 3-point arcs, LI arc, boop, boop. Any of these arcs, if you select them and stretch them, they stay with the circle that they were part of. The ones with AutoCAD just squirrel out all over the place and are totally frustrating. But these behave in a responsible fashion, as far as I'm concerned. Because selecting things is so basic in Enterprise, there isn't even anything on the ribbon for it. There are about 6 different ways to select objects. To select any single object, you just click on it and then can do whatever you want. To select multiple objects, with Revit, you select something, and to select another one is a Ctrl-click. Ctrl-click, and they turn blue to say that they've been selected. And then once they're selected, then you choose what you want to do with them. Move them wherever they happen to go. Like AutoCAD, we can select with a couple of different windowing options, and it works just the same way. To drag from left to right. As soon as something is entirely contained within that rectangle, it's selected. 1, 2, 3, 4. I'm going to do some little circles or something to make this a little clearer, I hope. So I'm not picking a select tool, anything like that. I'm just dragging from left to right. Dragging from right to left, as in AutoCAD, puts up the rectangle with the dotted lines, which is a cue that as soon as anything is even touched by the rectangle, the whole thing gets picked. Then you do it, change the color or erase them or whatever it happens to be. This tabbing and selecting works for lines as well as for, let's say, walls or other things that are linear and connected. So if I wanted to select all these guys, I could window them. Let's say that went to there. I don't want to window them because then I'd be picking up this stuff too. But if I hover over any one of these, hit Tab, it'll select the whole group. Then I click and do whatever I want to do with them. Connected end to end doesn't count for things that are sort of T intersections. If I realize I want all of those except this, that one right there, I can then, once I've got things selected, I can use shift click to deselect just that one guy. So that's handy if you've winded a bunch except for 2 trees or something, you could then shift click to get rid of them. And lastly, let's draw some more walls. And this comes up a great deal. I would like to select all these walls, plus all these walls, plus some somewhere else. I can select things by the kind of thing that they are. So if these are all the same type of wall, which they are, I can select this one, right click, and say select all instances. Let's say visible in this view. There might be some that are off the screen somewhere, don't know where. They're visible in this view, and it picks all those guys. Then we can change their wall type or whatever we want to have happen. Erase them, whatever. There's one rather more sophisticated way of doing this. Let me put in a desk. Let's say I want to select just the desks, and there's a bunch of them here. If we window everything, if I go up to filter, looks like a funnel, I can say of all those, which are the things that I want to select. I'm going to leave them checked. So let's just say I'm going to leave just furniture checked. It might be lots of different kinds of furniture, some chairs, whatever. Select all instances in view would pick up all the desks, but not all the sofas and everything at the same time. So if I just leave furniture sets checked, so then okay. So then just those are what's checked, and I can do whatever I need to do with them, erase them or change them or count them or whatever. And I didn't learn about that till like about 2 years ago, and it's really hugely helpful. I just didn't know what to do with it. Okay, release those. Oh, that's another thing that escape will do, which is let go of things that have been selected. Now, once you have created some things, Revit means the name comes from revise it, as opposed to erase it and make it again. Pretty much whenever you select anything, we have the modify tools are available to us, which include align, and we can watch the little video, which is say align that lower line with the top line. We can use offset, which we know exactly from AutoCAD. It's the same tool. We'll watch its little video. We have 2 different mirroring tools. One where we have a line that's already there, the center line of that wall, like we can mirror about that. Mirror where we have to provide the axis, like going from the middle of the window or somewhere, middle of the wall. A split element, this is like AutoCAD's break, where one thing becomes 2. And this is the one you sort of use for trimming stuff out. A split with gap. Hardly ever use this. It's really just for walls, where you might have, this is for tilt-up construction, where the walls are actually built in like 10-foot segments and flipped up. Move, copy, rotate, trim, which we looked at last time, and then the various extend tools. And then this is another way to do delete, just to pick something and hit delete. You can also hit it and hit the delete key. You can hit it and hit the backspace key. You can hit it and type E for erase, E for erase, E for erase, a bunch of different ways to do that because it's so common. I mostly use the backspace delete keys. One thing to be aware of when we're doing this, let's say I've selected these and I want to mirror them so that there's an upside down version up here. And I'll draw a line first to do that with. So if I window them and pick the mirror tool where the axis of reflection is already have it there, I have an option over here. This is called the option bar, and it shows up for a lot of the commands. Like if you're drawing polygons, this would say how many sides do you want. In this case, for the mirror command, is do you want this up here to be a copy, or do you just want to flip this one up there? And I'll leave copy checked and put it like that. If I hadn't done that, I windowed this, sorry. Window those guys, mirror, don't copy, get that. So very much something to pay attention to, and it's sort of in green when you do that, so it's a little, a little attention being called to it. When you're offsetting things similarly, copy is an option here as well. If I want to offset, let's say a foot, this guy right here, let's make it 2 feet. The basic unit of Revit is a foot, not an inch. That was hard to get used to, going from 20 years of AutoCAD with 12 meaning 12 inches and now it means 12 feet. And it still happens to me that I think I'm offsetting something 30 inches and it's way up on the roof. This also gives me a copy option. If I say yes, copy it, it does. You can also enter dimensions in terms of millimeters. Like AutoCAD, Revit has a bunch of cursor snaps built into it. So when you're drafting stuff, by default, Revit's recognizing endpoints, midpoints, same little shapes as in AutoCAD, centers of circles, midpoints of why is that an endpoint? Oh, that's the endpoint of the axis of the desk furniture component. But here's like the midpoint of this line. We can change which cursor snaps Revit uses for its running cursor snaps. If you decide I just never want the centers of circles, those are confusing me. I don't want to show those. I think that's in Manage Snaps. Here we go. So as in AutoCAD, we can choose which of those will be the running object snaps. So if I just never want to see intersections or centers or perpendicular or tangents or points, or if all I want to see is endpoints, I can do that, but I rarely do. These are just very helpful to have. I'll turn them all on. Check all. If you want to force the use of one particular OSNAP in a given situation, let's say that there's some endpoints or some intersections or some centers of circles very, very close to each other, and you want to say, no, I specifically want to address let's say the center point of a circle. Bottom of page 4, I have listed the object snap overrides, which are good just for the very next one. So like SC will snap me to the center of the circle and ignore all the other possible options. So I can be going here and picking up quadrant points. I can be going here and picking up a midpoint. I don't want any of those. SC will snap me to that center and only to that center. Not, maybe a center or something else, but to center points. And we have those for centers, endpoints, intersections, midpoints, nearest, just to make sure that you're actually touching something, perpendicular, quadrant points. Those are all the same as in AutoCAD. If you just want to turn snaps off, I go back up to snaps and check none of them. Don't even know what this is about. Let's turn them off. Use shortcuts listed above. All right, that's where those are. If I do that, then I do line, then nothing's snapping to anything. But as a rule, I don't want that. Check all. Okay. Okay, a couple of little geometry exercises to sort of get a feel for some of these tools and starting to use actually dimensions in one of the others. I can show you some Revit dimensioning quirks. Let's find the length of the diagonal of a rectangle that's 34 feet by 21.6. So LI, rectangle, click. I'm just going to get close here. Selecting one of these lines will give you its distance from other parallel things nearby. And we can see here, selecting this line is telling me that it's 19.6 from this line down here. And we decided we want it to be 21.6. What we're seeing now is what's called a temporary dimension. You pick the object that needs to move, select and edit the temporary dimension, and then escape. If this is the line I want to leave where it is, and this is the line that I want to move to make it 34 feet, I'll select this one, click the dimension, and type 34. No feet marks necessary, unless you'd like to do that. And then drawing a diagonal line, I'll snap to endpoint and endpoint. And a couple of different ways to see how long that is. If your properties palette is turned on, you can select it and see that the length is 40 feet 2 and 187,256, which is close enough for government work. Let's put some actual dimensions on this instead of just the temporary dimensions. Because dimensions are annotation objects, we'll pick annotate. And we got the very first thing that comes up is dimensions. We got a couple of different ones. The aligned one is showing that we're doing it between two parallel lines, whether they're this way or this way or this way. That's really Revit's preferred mode of dimensioning things. So let's pick aligned, and it's going to do it between this line and anything else that it's parallel to. So we pick and pick, and then we can place the dimension where we want. Same thing going up. Pick and pick. Clicking the lock icon will make it so you can't move either of those two lines unless they move together. There are a number of similar locks and constraints we can apply to objects. We can pin an object in place, like a column. You don't want to set up a bunch of dimensions and lock the dimensions. You just want to say this column can't move, so you can pin it. Now, another option with aligned dimensions. In a number of operations in Revit, where selecting a given point might let you select a couple of different things, depending if it's a center point or an end point of a line that comes to the center of the circle. And we can use the tab key to move between different things that we might want to be dimensioning. And what I want to do is I want to dimension from this end point to this end point. And Revit doesn't actually have a just dimension this object out to here, for instance. It can do it for walls, but not for lines. I have to measure from a point to a point. So I'll use that align tool again. And I'm going to get my cursor down here near this point and hit tab until the dot shows up. See that dot? That means that endpoint. And then I'll go up here and do the same thing. Tab, 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 dot, and then I can see what that is. And that's a little tricky. Sometimes the dots are so small you can sort of can't tell that they're there, but it's when nothing else shows up, that's because it's the dot. So my next question for you is not a dimensional question, it's a geometry question. Indeed, what I'd like to do here is talk through what it would take to make that perfectly. Imagine that this is perfect. If you were drawing this by hand, how would you do that? And none of this involves any angles. How would you know which points to go to? I'm not trying to put you on the spot, but think of this as a final result that might have some construction lines that we erased. What construction line would give you like the 5 points? What shape would give you those? Well, we're trying to draw a star, but that's not that's in SketchUp, but it's not in Revit. Polygon. Who said polygon? Pentagon has to be 12 inches across, has to be a whatever. So that's going to be, let's do this annotation lines. What the heck? Annotate, detail line, polygon. Now we have two. This two kind thing, and I always forget which is which, whose vertices are a specified distance from the center. So that means from here to here. Good. We know we want that to be 6 inches because the whole thing is 12. So let's do that one. Well, we want to draw first a polygon to get those points. And then remember the option bar? Now that shows up for polygons. We need to say 5 sides. And we know that its radius is 6 inches. And that's little compared to everything else. Oh, and that when I'm drawing that, I should have zoomed in here close enough to see that my line is coming straight up to the top. So now we can indeed draw the star that you suggested. That can just be lines that go, again, clicking to endpoints. Now, I don't know how we're going to find the center of the circle. In retrospect, I think we need to draw the circle early on because it's going to be hard to come back to find that point to draw it. So let's do this. So drawing a 6 inch build, not 6 foot, 6 inch. There's that. And then I can draw a polygon, 5 sides. I'll use SC for snap center. And come right up. I can snap to the quadrant point right there. And then draw these lines. And then get rid of the pentagon. It served its purpose. And I regret that Revit doesn't have that nice trim tool where you just pick this little part and it goes away. It's a little more laborious. What we need to do here is basically break each of these lines and then use the trim command. So in Revit, modify. This is the split element or break command. I'm just going to break each one of these at its midpoint. And then use the trim extend tool. To trim out each pair. Of course, I forgot to do it over here. Split element. And I think the point of this is, as designers, we're going to be creating things that don't yet exist. A new piece of furniture, a new light fixture, something or other like that. And it might be that there's no direct route to just drawing a rectangle and making it happen. You might have to have a couple of steps to get to the geometry you want. And don't be afraid of that. Just think through what you want to end up with, and then maybe work backwards to the things that you know to be able to get to things that you want. with these drafting tools kind of in hand, I would like to start a new drawing and start talking about walls and what's in them and how to draw them. So we start making some use of this. And we could just, well, we can get rid of all this. I don't want to erase the elevation markers. Oh, you know what? Let me try this. I'm going to window. If I window everything and filter, I don't want to delete my elevations. No, so not my views either. Okay. Okay, that close enough. You can pick them. I just wanted to get a clean slate here. Let's, I always start building a simple building. Let's do a simple little like L-shaped building with an architectural wall. But instead of just this basic sort of generic wall made out of gray stuff, I want to use a real wall. Let's say an exterior wall with brick on metal studs. And we'll draw it first and then come back and look at it later on. As you go around, you'll notice that as I come back down here, well, of course it doesn't work this time. Usually what happens is I get a little line going across there to tell me that if I had intersection OSNAP turned on, that line would have appeared. So right now we're seeing this view, this wall in a view with our lowest level of detail. Down here, the bottom corner, we have a button that lets us increase the level of detail so we can start seeing the materials that this wall is made out of. Let's just take that to fine. And we can zoom in to see that we have an interior layer to this wall that's probably chipboard or plaster. We've got a layer for metal studs. We've got a layer of sheathing. We've got a layer of, this is probably an air gap. We'll take a look. And then a layer of brick on the outside. So this isn't only something that is sort of in section. If we go to our 3D view, we can see that we indeed do have a brick on the outside. This brings up a point. You really have to have your properties palette turned on to work effectively, because that'll be the current piece of furniture inserting. It'll be the current window, the current wall type you're using. That's where you make those choices. I have this over on this side, just so I sort of don't get these two confused. I used basic wall, exterior, brick on metal stud. Now I use the WT window tile command to see both windows at the same time, and ZA zoom all to fit them both to the screen. It takes time and computational energy to put up the brick patterns on things. You see, mine's gray right now. That's not brick. And so at some point, Revit decides, I'm not going to bother drawing every individual brick. I'll just make it gray, just zoom in, and there it is. Each of these walls, every wall in Revit has an inside and an outside, even if it's just indoors. But what I want to show you here is if I select this wall, which is this guy, and you know that we can flip the sides of a wall. We can put the brick on the inside. But what the little flipper arrow here is doing is telling you this is the outside of the wall. If I flip it, then I've just put the brick on the inside of that wall, which is not what I'm looking for. So for an interior partition where it's just chipboard on studs, it doesn't matter which is which. But for an exterior wall, it's clearly important. And also that means at the corners where a wall is drawn correctly with the brick on the outside isn't going to meet that cleanly with one that has it on the inside. So I'm going to select this again, click its arrow to switch out, and get back to my bricks. The reason to be able to show different levels of detail, when you're doing a wall on like an 1/8" plan and your wall's about this thick, if you have all those lines in there, it's just going to be like a totally blobbed out solid wall. So at that point, you kick it back down to either a medium or a coarse view. and just show the outlines of the wall. And then in a detail view, or where it's important, where trim or something goes, then you can, at a larger scale, then you can use finer detail. Now, the way that every wall is put together, well, let's look at the big picture first. I'm going to pick this wall down here, and in properties, I see that its base constraint, which is say its bottom, is right at level 1. At this point, it goes up just 20 feet high. It's not tied into a second floor or anything. It just goes up. If we would like that wall only to go up to level 2, we can go to its top constraint, and instead of unconnected, say up to level 2. And then it goes just as far as that. So that's how we set where it starts at the floor level and where it ends. And if you remember from Monday, we can also have it extend up until it hits a roof, wherever the roof happens to be. Okay, so we have walls. They've got inside and outsides. They've got a top and a bottom. Sort of defines where they are. When we're drawing each wall, we have three ways to draw it. Structural engineers almost always draw their walls using a center line, like sort of a point from here to here, because they're gonna have a column here and a column here, and they want all those to line up on their centers. So if they're putting in concrete walls, concrete CMU walls or something like that, they will almost always be called center justified, drawn with the center line. And they actually, the cursor is here, and then the cursor is here, and then the wall goes out in either direction from there. In a case like in here in LL25, we don't know how thick any of these walls are. We haven't measured the outside, we've only measured the inside. So here, we would want to be, sort of do another little room like this. Let's say we had a room that we knew was the inside of it. We don't know what the outside is. Let's say 30 feet by 20 feet. So to do that accurately from the information that we know, we go architecture, wall. I'm going to keep using this exterior brick wall and metal studs. But you see here, we have the choice of, as you're drawing 2 points to define a line, is that the inside of the wall or the outside of the wall or the center line of the wall? And we want that to be the finished face of the interior. So as you're doing your apartments, you're probably using finished face interior, since that's what you know, finished face interior. And as we start drawing that first line, which I wanted to be 30 feet, and then you see it hits that inside point, and then from there, I'm going out the 20 feet. Now to check this, I actually put a dimension along that line. We have to be a little careful here, because there's a lot of potential things that we could be dimensioning to. So when we go to dimension, annotate aligned, we can see that I can dimension to the wall center line, which is right down there. So it's like, 6 inches on each side, or to the wall faces. And I would suggest we do wall faces, because that's what we know about here. So I can pick that line. And right now it's only going to either to a face or to a center or to an outside face. I don't have to worry about snapping to the face of the studs there. We got the 20 feet. So Revit's not trying to enforce any particular way of doing it, but making sure that we are aware of the options and use the correct one. And there is another way to do this, aligned. Again, under options, once I picked wall faces, it can say, do you want to measure from point to point, or you just want to measure the whole wall. So let's say entire wall, and I'll pick in here. And that's maybe an easier way to do that than having to go from counterpoint to counterpoint. The effect is the same, whether you're picking one thing or picking two. So two different ways to do that. I almost always do it point to point, just so I have a very clear sense of what I'm doing. I think I'll wait till next week to talk about the internal structure of walls. We can draw curved walls. We have with walls the same options that we have with lines. Let me get rid of this one, actually. And I would like to do a arced wall here. Let's see if we can make that happen. So wall. Yeah, that'll be right. There we go. Let me see what a roof here would be like. Just a second, I've never tried this before. Architecture, roof by footprint. Yes. Okay, so you know, can start doing stuff like that. Oh, that's here. Okay, just playing with walls. I think I'm done. Going into the pieces of a wall, I think is just something we'll wait till Monday till I'm fresh. And you are. Have a great weekend. No homework. Even better.